Now, this is another question, okay, on Hess law. And please, the general idea is this, it's simple. I need you to just pay attention, please. It's not hard. It's not hard. Everyone sit up. Sit up. Yes. Okay? Just understand how it goes. Okay, I need to be clear. Now, I told you that you always have individual reaction. Then you have a general reaction. Okay? You have a general reaction, you have individual reactions. Now, these individual reactions would actually help you to solve your general reaction. Okay? To solve the enthalpy for your general reaction. It's the enthalpy of your general reaction you're looking for. But the enthalpies of the individual reactions will actually help you to get the enthalpy of your general reaction. Okay? Are we together? So now, what I'm saying is this. If peradventure we get our enthalpy of the general reaction, it is as a result of having rearranged the individual reaction. We must rearrange it. And I told you that how do you rearrange? You rearrange by checking the entities that are on the first reaction that you will not see on the second or the third. If it's the second, check for the entity that you will not see on the first or the third. If it's the third, check for the entity that you will not see on the first or second. Check for that entity that you will not find on the other reactions. Now let us start with the first reaction, the first individual reaction. We have 2NO plus O2, then we have 2NO2. Alright, our delta H is minus 216 kilojoules. Alright, now let us check on this first reaction what we will not see on the second or the third. Now, NO is NO on the second or third? Is NO anywhere on the second or the third? Yes. Why say yes now? No now. Do you see NO here? Do you see NO here? Where is NO here on these two? Will you see NO on any of these two? So why are you saying it is there now? Why are you saying yes? NO is NO here? Is NO here? This is NO2 for crying out loud. It is not NO. NO and NO2 are they the same? CO and CO2 are they the same? No. Alright? So that is the idea. Now, NO is not on any of these two equations. So what we have to do is simple. Okay? Now, since we have been able to realize that it is NO that we will not see on the second or the third, let us check on the general reaction. Now, that one that you would actually check that is not on the second or the third would be the general reaction. So check where it is located in the general reaction. Are they on the same side? NO is on the reactant side here, but NO is on the product side here, right? Good. So the fact that they are not on the same side, it means that we must swap this NO in the individual reaction so we can get it to be on the product side here. So now we'll come to say rearranging. We'll rearrange these three equations. Alright, we'll rearrange these three equations. And look at this, guys. Now this NO that is here, we have to ensure that anything we are doing to these three equations must correlate with what? The general reaction. Alright, it must be equivalent to what the general reaction represents. So NO is here, but NO is on the product side. So we have to do it in a way that NO will come what? Will come on the product side. And how do we do that? We swap. Okay? We have to what? Swap. But now another thing you should also take note of is that NO is 2 here, but NO is what? NO is how many here? But NO is what here? And we have to now make the individual reaction to be exactly as it is. So how can we get one NO to be on the individual reaction? When we divide by what? So we divide everything by 2. Is that okay? And anything that we divide, it will also affect the change in H. As we are changing the signs, alright, we are changing the sign because we are swapping. So when we swap, this minus will become plus. Are we together? So now let's look at this. So we would divide, okay? So let us swap first. So this will be 2NO2, okay? To give us 2NO plus what? O2. Our delta H will change from minus to what? 216 what? Kilojoules. So now we have to divide by what? 2. 2 cancel 2. 2 cancel 2. This will now be 1 over 2. Am I correct? Why? This 216 divided by 2 is what? 10 what? 108 what? Kilojoules. Do you understand? Do you understand?
Yes.
Okay? So now, that's what we did. Alright? So this is what we now have. Now if you look at it now, we now have NO2. NO is NO now the same with the general reaction. So it means that after cancelling now we have NO2 to what? NO plus 1 over 2 what? O2. And our delta H is now 108 what? Kilojoules. We now have NO. The reason why we are focusing on only NO is because NO was the only entity in this first reaction that we did not see on the second or the third. That's why we focused on only NO. Now let's go to the second reaction. The second individual reaction. We have 2N2 plus 5O2 plus 2H2O to give us 4HNO3. Our delta H is minus 346 kilojoules. Alright? So now look at this, guys. In this second reaction, what is in this second reaction that we will not see on the first or the third? Is it H2O? Is it H2O?
Yes.
Alright, which other one? Is HNO3 on the first or the third?
No.
So it's H2O and what? HNO3. Leave the 4 first. It's H2O and what? HNO3, right? Good. Now, let us check on the general reaction. Let's check on the general reaction. We have H2O on the reactant side here, and we have HNO3 on the product side here. Are they on the same side?
Yes.
So do we need to swap? No, but what we need to do is to ensure that we have the same H2O. H2O is 2 here, right? HNO3 is what? 4 here. But it's 4 here now. While it is 2 here. This one is 2 here. Why this one is what? And we have to make it to be like the general reaction, right? So what do we do to these guys? We have to divide by what? We divide by 2. So when we divide this 2 by 2, we now have H2O. When we divide this 4 by 2, we now have what? 2HNO3. We also have to divide our delta H by 2, right?
Yes.
So now let us do that. So we have to divide everything by 2. So now 2 divided by 2 will give us what? N2 plus what? 5 over 2 what? O2 plus what? H2O to give us what? 2HNO3. Our delta H will be what? Minus 346 divided by 2 give us what? Minus what? 173 kilojoules. Do you know why it's still carrying minus? Because we did not swap. Right? Because we did not swap. That's why it's still carrying minus. Is it clear? Yes. Now let us go to the third equation. Alright, let's go to the third equation. Now in the third equation, alright, in the third equation, what do we have here that is not in the first or the second? NO2. N2 is here now. Why is it N2? N2 is here. Alright? It's NO2 that you will not. NO2 is also there, right? O2 is also there as well. So everything here is on the first and the what? Second. So do we need to touch it?
No.
Do we need to swap?
Yes.
We need to swap, right? Now let's first of all leave it, okay, as it is. Remember the other one I solved, okay? We only swapped when we realized that swapping was the only way we could cancel, right? So if you look at this one like this now, you realize that it is not on the first or the second, okay? It's not on the first or the second. You will not also find, it's only 2NO2 that you find on the general reaction. But now just leave it like that first, because you have what N2 and NO2 on the other equations. So let us leave it like that first. Alright? So let us leave it like that first. So we have our N2 plus 2O2 to give us what? 2NO2. Our delta H is what? Is what? 298 what? Kilojoules, right? Alright. So now, at this point, we are done rearranging. Although, like I said, there's a tendency that we will also touch the what? The third reaction again. But now let us check if there will be any need touching it. Alright, so now let's look at these guys. Please, this is an arrow, please. Alright, let's look at that. Now, let us check. Now, NO2. Remember, you can only cancel things that are on the opposite sides, but you add things that are on the same side. Cancelling on the opposite side means subtraction. It's not as if you're dividing. You can only divide things, you can only subtract things rather that are on the opposite side, but you add things that are on the same side. Do you understand? Alright, so now look at these guys. Now let us check. Because this is general reaction. This is what we are trying to achieve. This is what we are trying to achieve. Let us look at NO2 first. NO2 is 1 on the reactant side, right? But that on the product side it is what? But on general reaction it is what? 3, right? So what does it mean? What does it mean? It means that we have to what? Because it's only when we swap that we can add. So we have to swap this third reaction, because it's only when we swap that we can what? Add. That is why I told you, don't just be quick to swap when you realize that there is nothing on that reaction that you, okay, both things on the reaction rather you find on the other two reactions. Don't be quick to swap. Alright? Only swap when you realize that the only way to cancel or to add is when you swap. Alright? So now look at these guys. NO2 is there, but 2NO2 is here. If we mistakenly cancel, guys, we will be left with only NO2 here. But do you see NO2 on the product here? No, because what we are trying to achieve is the general reaction. So it means that we have to clean this guy. Alright? We have to clean this guy. Then we will now swap. So now let us swap. So it means that we'll bring 2NO2, right? Then to what? N2 plus what? 2O2. And delta H will also change to what? Minus. So this will be minus 298 what? Kilojoules. 298 kilojoules. Alright? Let us now add and subtract. Is there anything we have to rearrange again? No. So now let us cancel. N2 can cancel here, right? Is there any other thing that can cancel? Our O2 is in not. 5 over 2 O2 is on the reactant side. Okay? Which other thing is on the reactant side? Which other O2 is on the reactant side? Please be very careful that reactant sides are on the left side of your arrow. Okay? Then look at on the product side. 1 over 2 O2 and 2 O2, right? 1 over 2 plus 2 is what? 5 over 2, right? Remember, we can only add on the same side. If we add this guy to this guy here, it will cancel this guy. Because this plus this is 5 over 2. And 5 over 2 can cancel 5 over 2 O2 because they are on opposite sides, right? Now, is there any other thing that can cancel? Is there any other thing that can cancel? Look at it very well. Nitrogen. Our NO2 is here. Our NO2 is also what? Here. How about water? Our H2O. We cannot cancel, right? Because there's nothing to cancel it, right? So now, let us now add NO2 and 2NO2. So NO2 plus 2NO2 will give us what? 3NO2, right? Good. Now, still on the reactant side, let us check if there's any other thing on the reactant side. H2O is on the reactant side, right? So plus what? H2O. Is there any other thing on the reactant side here? No. Then let's write our arrow. On the product side, we have what? NO, right? So NO plus what? 2HNO3. Is it not the same with the general reaction? Or is the same thing? Or don't mind the fact that NO is here and it's still on the product side. Is that okay? So now our delta H now will be to add all our enthalpy changes. So we have 1 over, remember we have 1 over 8, we have minus 173, and we have minus 298. 1 over 8 minus 173 minus 298 will give us what? Minus what? 363 point what? Any decimal? Just minus 363 what? Kilojoules. So this is the delta H for the general reaction. Alright? So that's it. So that is that for this particular question on Hess law. Alright?